Question says, how does Manchester encoding differ from differential Manchester encoding? There are few differences. A negative to positive transition represents binary 1 and a positive to negative transition represents 0. That means suppose we have a bit 0 and we are at a high voltage. In that case, we make a transition from positive to negative, that is like this. And if we are at a low voltage, we make a transition like this. And in case of bit 1, this is low voltage. In case of bit 1, we make a transition from negative to positive, that is from low voltage to high voltage. That is, if we are at a low voltage, we make a transition like this. And if we are at a high voltage and we have bit value is 1, then we make a transition like this in case of bit 1. So this is for Manchester. And for differential Manchester, no transition at the start of a bit period represents 1 and transition at the start of a bit period represents 0. That means if bit is 0 and we are at a high voltage, that means we start from a high voltage and come back to high voltage again. And if we are at a low voltage, suppose we are here, we start from low voltage, come back to low voltage again. That means if we see this is the start point, we make one transition here in the start of a bit period. And in low voltage also, we make a transition in the start of a bit period. That is, when bit is 0, we make a transition at the start of a bit period. Now, in case of bit 1, in case of high voltage, that means if we are at a high voltage, we make a transition like this. And if we are at a low voltage, that is, if we are here, we make a transition like this. That means in the start of a, if we see that this is the start of a bit period, this is the start, we didn't make any transitions. So that is the difference between Manchester and differential Manchester encoding. Another difference is Manchester requires a clock signal for synchronization, whereas differential doesn't require explicit clock signal for synchronization. Another difference is it provides better signal synchronization, and in case of differential Manchester encoding, it provides less signal synchronization as compared to Manchester encoding.